So we're actually not going to talk about agents, believe it or not. It's what we're going to talk about is somewhat complementary to agents and somewhat complementary to what we do, but we just think this is a pretty interesting topic. We wrote a blog post a couple weeks ago called "The Future and Present of AI Synthetic Data," and we just want to talk to you about some of the things that we're thinking about at Sutro with regard to this. So all of these models have something in common. They all released this year. They're all frontier models. I guess I already kind of spoiled it, but what's interesting about them is that they're all either fully or mostly trained with synthetic data, at least either confirmed or speculatively. There was a big question around it about a year ago where people were all saying, have we hit the human data wall and our scaling law is going to sort of stop from here? And in some regards, human data is more important than ever. But we've also figured out how to take the data that we use to train our models and amplify its utility with synthetic data to a pretty extreme extent in the last year. And I'm not sure that many people are noticing this. So this was a tweet from Elon the last several months. He said, most training in the future will actually be inference for the sole purpose of training, aka synthetic data generation. So I'm not sure if that makes sense, but basically a lot of the compute budget is going to generating massive corpuses of synthetic data, and that budget is actually sort of counted in the training itself. What we actually see in certain customers that we work with is that the weight update steps are actually not the bottleneck, it's inference. They're generating massive amounts of synthetic data and doing massive amounts of evals on that synthetic data to actually train the models. And so this actually changes the economics of things quite a bit. I'll get into that in a moment. Zuckerberg also has a pretty interesting quote about basically self-improving systems. I don't want to speculate too much on that. I don't work for Meta, but we have some ideas about why that might be as well. Synthetic data has been around for a while. It's a pretty boring topic. I think people, it's sort of like a graveyard of companies in the space and whatever. What changed about it since the advent of LLMs? We think there's a few things. So first, the technology changed significantly. I have this little diagram up here, but what we find really interesting is that you can sort of map between representations and modalities pretty seamlessly with LLMs. This is not something you could really do before. So you can't, so in this little like wheel diagram I have, you can sort of take like a structured patient data, for example, and create a fully synthetic clinical note from that, and from that use a text-to-speech model, create an audio recording. You can embed all of that and make it semantically searchable. You can also go in the complete opposite direction. If you have an audio recording of a patient visit, you can create the transcription, you can create the unstructured text, and from that you can do structured extraction and pull it into a structured format. And you can do this on millions and billions of rows of data rather inexpensively, sort of at your will today. The next thing that changed is the methodologies. Something that only kind of really became possible this year was that the previous generations of models can actually train the next generation of models. We've seen OpenAI was actually using synthetic data from o1 to train GPT-5. That's something that wasn't really happening before. Reasoning models, tool calling, web search, reinforcement learning, these things are actually working now. And so you can sort of have LLMs go off and bootstrap entirely new domains of knowledge that are pretty reasonable to pre-train on. So like an example might be space law. Like there's not that much known about it, but you can actually probably have an LLM go generate a massive corpus of information on it, kind of call back to what's known in like legal law and space technology and whatever, and actually create like a pretty reasonable corpus of pre-training data that enhances what's already in there. And this is sort of how humans have learned for thousands of years, just sort of building new tools, creating new combinations of knowledge, and then sort of repeating. And LLMs can do this way, way, way faster. So the learning loop is tightened. And like I was alluding to earlier, the economics have changed quite a bit. So training used to be these like reserved massive clusters for pre-training, sort of like massive CapEx spend, right? But that's not really what it is anymore. Like we were saying earlier, customers that we see actually generate a massive amounts of synthetic data, which are sort of embarrassingly parallel operations. You can spin up hundreds of GPUs at once, use inexpensive spot nodes completely offline, and generate just massive corpuses, run basically LLM adversarial evals against them, make sure that the data is actually high quality, and then do the weight update steps from there. So it really is kind of moving from this like one-time large CapEx thing to let me use a very powerful pre-trained Quen model or something like that, and then do the last 5% of training based on synthetic data. So the blowback of this is that the cost of producing, curating, evaluating data and models actually plummets, and it becomes an ongoing process. And then finally, the legal landscape has changed. So closed model providers have this thing of like not allowing you to actually use outputs for synthetic data to train your own models. This is pretty much all of them. But this year, pretty much starting with DeepSeek R1, it ushered in this new era of frontier, freely licensed models that you actually can do this with. So you can take DeepSeek R1 and generate all the synthetic data you want, and you can take Quen 235B and these other big models and Kimi K2, which are super, super powerful, and actually legally do this now instead of behind closed doors. So we're going to see like a lot of companies basically spawning new model generations just based on these freely licensed architectures. And this chart on the right is the sort of closed, open frontier as of in the last week. So what's in it for folks in this room? I assume most people here are not from the big foundation model companies, so it has to matter to you a little bit in other ways. Faster product iteration is one thing. You can generate massive sort of test data, labels, feedback, et cetera, on demand without human feedback, without human labelers. This is a very big deal in certain circumstances that don't require human expertise. Yeah, like I said, model customization improvements, sort of distillation. It's now like pretty much legal where it wasn't before. So you can very easily create a task-specific or world knowledge-specific model from an open source LLM where it was like pretty much illegal before, but you could create a competing model doing that now. You can reduce risk, right? So you can create synthetic paraphrases of data that you might have that might otherwise not be compliant, it might not otherwise be portable, you can't train on it, but you can take entire corpuses of data and basically create synthetic mocks using LLMs that can be used for a whole bunch of things. And then there's this LLM as an eval thing. We have a blog post we recently, or example guide that sort of uses these adversarial and ensemble strategies for curation of sort of data and evaluating models. So who are we? Why do we care about this? We are Sutro, a very relatively new company. We're focused on high throughput, sort of offline batch inference. It's basically managed service today. It's fast, it's cheap, it's pretty near infinitely scalable. It's invoked with a very simple Python SDK. And one of the main use cases for our thing today is synthetic data generation, as well as evals. Companies like SynthLabs, the post-training lab, use us to generate billions of tokens at a time for RL evals, distillation, and more. We think Sutro is one of, if not the best tools to use for synthetic data generation. He said fast, cheap, observable, collaborative, secure, very easy to use, customize, and integrate with other things. I'm not going to read all this off, but I can tell you, preach the good gospel later. Like I said, also pretty effortless SDK. It's really like, there's literally 2 lines of code to invoke. This will generate 100 rows of synthetic data. Probably not very useful. We have a guide on how to generate actually useful synthetic data. There's several of them that I'll pull up in a moment. Like I said, seamless scaling. So this is now generating 10 million rows of synthetic data with 1 line of code change. This is sort of what the UI looks like, sort of firing off all of these jobs that are sort of very observable, trackable, detached, stateful, et cetera, that you don't have to worry about managing your sort of distributed GPU cluster to do it. And then you can go in and actually like see the results as they're being produced and what sort of comes out of it. So this is the early product and sort of behind the scenes. These are some helpful resources to get started. I mentioned we have some guides as well as sort of the blog post form of this talk. If anyone wants to QR code these, they're also just like on our website. Happy to show you where they are. Yeah, some socials and like how to get in touch with us if you care about these sort of things. And then we have these like early access cards, a whole bunch of them with unique codes for early access and like $250 in free credits and 10 billion tokens. Because it's offline inference, it's quite cheap, like I said. Come find me after if you want to talk. We're in the startup booth area, but thanks for your attention and letting me close this out.